Welcome back to my channel, and today we'll be discussing factorization using the HCF method, right? The highest common factor. So first, let's refresh ourselves on what a factor is, right? So factors, these are basically two or more numbers which you are multiplying in order to get a specific number. So let's say you wanted the factors of 4, right? The factors of 4 are 1, 2, and 4. Because when you multiply 1 by 4, you get the specific factor of 4, the specific number of 4. When you multiply 2 times 2, you'll get 4. So hence the factors of 4 would be 1, 2, and 4 as shown right here. Alright? Now, let us discuss what the highest common factor would be, right? The highest common factor is basically a number, is basically a factor which two or more numbers have in common, right? So let's say you wanted the HCF between 6 and 18. First, you list the factors of 6, which are 1, 2, 3, and 6. Next, you list the factors of 18, which are 1, 2, 3, 6, 9, and 18. So if first look now, we're going to compare the factors which they have in common, right? Which are 2, 3, and 6. So between 2, 3, and 6 now, right? Which one would be higher? Because the highest common factor we're looking for, that's 6. Hence, 6 would be HCF between itself and 18. So now, let's look at these examples with numbers, right? Not numbers, sorry, with letters, right? Or variables. So let's say, for example, if you wanted to find the HCF between a and a squared, right? You know a can be rewritten as a to the first power. So the factors of a would be a to the 0, right? And that's the same as 1, right? Anything raised to the power of 0 is 1. This is where laws of indices come in handy. And a to the first. So these are the two factors of a, right? And now we're going to list the factors of a squared, right? Which are a to the 0 power, right? A to the first and a to the second, right? You may be wondering how we'd just get a to the first and a to the second as like factors of a, right? But for a to the first, it'll be a factor of a squared, because when you multiply a to the first times a to the first, right? Remember in the laws of indices, when the bases are the same, you keep the base here to add the powers. So it becomes a to the power of 1 plus 1, which will give us a to the power of 2. So whenever you're multiplying, right, you'd add the powers, right? If you're dividing, you'd subtract. But in this case, when you multiply a to the first by a to the first, right, you get the a squared, right? And a squared is a factor because every number or letter would be a factor of itself. All right? So now, if we're to compare the factors of a to the first and a squared, right, the highest common factor obviously would be a to the first power, right? So a to the first power is the highest common factor between them, all right? And now let's look at another example. The HCF between b squared and b cubed, right? So the factors of b squared would be b to the 0, right? B to the first and b to the second. And the factors of b cubed would be b to the 0, b to the first, right? B to the second, and b to the third. So if we're to look, the highest common factor, right? Common factor between them would be b squared, right? Because they both have b squared in common, right? And it's the highest number. Hence, b squared would be the HCF between itself and b cubed. All right? So now, what we would do is to go through some common examples. All right? So we're going to go through some common examples. So let's say, for example, if we had let's say, for example, we had 7x squared minus xy, right? what we need to do is to take out what's common to both, right? And if you realize they have x in common, because 7x and minus xy, right? They have a letter in common of x, right? So what we need to do is to look between the x squared and the x, right? And find the HCF between x squared and x. And first, we'll list the factors of x, right? Which are x to the 0 and x to the 1, right? And then we'll list the factors of x squared, which are x to the 0, x to the first, and x to the second. So if we're to see, both of these would have x to the first as the HCF. Hence, we can just factor out x, right? As x is common to both. And now, what we'll do is to divide x into 7x squared minus xy, right? So first, we need to see how many times can we get x into 7x squared, right? So if we realize, we can see how many times can we get x into x squared, right? So let's divide that, right? So whenever we're dividing, we'll subtract the powers. So x and x to the first power is the same thing, right, as already established. So x to the second divided by x to the first should just leave us with x to the 2 minus 1, which should just leave us with x to the first power, or x, right? So this will just leave us with x at the top, right? So we have a 7 and we have an x, so we're just left with 7x, right? So therefore, 7x squared into x, so just leave us with 7x. And now we need to see how many times can x go into minus xy, right? So now we're going to have minus xy, right, over x, right? And the x will cancel each other, right, as we'll go into each other one time, just leaving us with minus y. So we're going to just write the minus y in the bracket and close the bracket. Hence, this is our answer. X open bracket 7x minus y. Let's go to another example, right? This one is a question of C6, right? It is a cubed minus 12a, right? So as usual, we'll take out what's common to both. And what's common between a cubed and 12a is the a, right? So the letters have something in common. So what we need to do is to find the HCF between a cubed and a, right? So the factors of a are a to the first power, are a to the 0 and a to the 1, right? And the factors of a cubed, right, are these are a to the 0, right, a to the first, a to the second, and a to the third, right? So now what we would do is to look at what they have in common, their HCF, which is a to the first. So we'll just factor out a, right? And now we need to see how many times can a go into a cubed and minus 12a, right? So a cubed divided by a will just leave us with a cubed, right? So a cubed divided by a to the first will just leave us with a to the 3 minus 1, which is just a squared, right? So we'll just write the a squared in the bracket because a cubed divided by a is a squared, right? And now we'll just see how many times can a go into minus 12a, right? So minus 12a over a. So the a's will cancel each other, right? Just leaving us with minus 12. So hence our answer is a open bracket a squared minus 12. Now let us go to another one, right? So let's say, for example, if you had 3x cubed minus x squared, right? What should be common is x, right? X is common to both. So what we would do is to first list the factors between x cubed and x squared, right? So the factors of x cubed, right, are x to the 0, x to the first, x to the second, and x to the third. And the factors of x squared are x to the 0, x to the first, and x to the second, right? So now, if we're to look, the HCF they would have is x squared. Hence, we can just factor out x squared, right? So now, we want to see how many times can x squared go into 3x cubed. So it would be 3x cubed over x squared, right? So we can see how many times can x cubed go into x squared, which would be x cubed divided by x squared, right, would be equal to x cubed raised to the power of, so it'd be x raised to the power of 3 minus 1, as when the bases are the same and you're dividing. You will keep the base and subtract the powers, right? So it become x to the 3 minus 2, sorry, not 1, which should be x to the first power, right? So I just leave us with x. So x cubed into, sorry, so x squared into x cubed will just leave us with x, right? So over 3, so we will left with 3x, right? And then now we'll see how many times can how many times can x squared go into minus x squared. So it's going to be minus x squared over x squared, right? Which is just going to leave us with minus 1. Hence, we write the minus 1 in the bracket. So our answer will be x squared, open bracket, 3x minus 1. Let's go to some more examples now, right? This one is going to be off of a CSEC past paper, right? So let's say, for example, if you had 2x cubed minus 8x, right? In this case, right, first you need to see what's common to both. If you realize you have two numbers, right, as the number part of it, we have 2 and 8, and we can get an HCF between 2 and 8 as well, right? And also we have, they both have x in common, right? So first let's find the HCF between 2 and 8. So the HCF of between 2 and 8, right? So let's first list the factors of 2. You have 1 and 2, right? Just 2 factors. And now let's list the factors of 8. You have 1, 2, 4, and 8, right? So now if we're to look which number they have in common, 2. So 2 is the only number they have in common, right? So it will be the HCF automatically too, right? So the HCF between 2 and 8 is 2. So we can factor out a 2, right? Now we need to look between x cubed and x. We need to find out the HCF between x cubed and x. So the factors of x cubed are x to the 0, x to the first, x to the second, and x to the third, right? And the factors of x are x to the first, are x to the 0, and x to the 1, right? So if we're to look, they all have x in common, right? So x to the first. So therefore we can factor out the x, right? And now we can open our brackets. And now we want to see how many times can 2x go into 2x cubed, right? So it'll be 2x cubed over 2x, right? So the 2's will cancel each other, right? So now we need to divide x to the third power. So it'll be x to the third power divided by x to the first power, right? We just leave us with x to the 3 minus 1, which is just x squared, right? So therefore, we're left with x squared, right? This will just leave us with x squared. So just write the x squared in the bracket, right? And now we need to see how many times can 2x go into minus 8x, right? So therefore, if you look, the x's will cancel each other, and 2 goes into itself one time, 2 goes into -8, -4 times. So just write -4, right? Hence, our answer will be 2x, open bracket, x squared minus 4. So now, let us look at another one, right? For y cubed minus 6y, right? For y cubed minus 6y, right? So what we need to do is to first, if you look, we can find a HCF between 4 and 6, right? And if you realize the y's, they have y in common. So we can first start by finding the HCF between 4 and 6. So first, let's list the factors of 4. The factors of 4 are 1, 2, and 4, right? And the factors of 6 are 1, 2, 3, and 6. So if we are to look, the HCF between 6 and 4, right, would just be 2. So therefore, would factor out a 2, right? That would definitely be factored out. Now we need to find the HCF between y cubed and y, right? So the HCF between y cubed and y, let's first list the factors of y cubed. These are y to the 0, y to the first, y to the second, y to the third. And now let's list the factors of y, or y to the first. So you have y to the 0 and y to the first. Hence, the HCF between both of them would be y, between y to the first or y, right? So also factor out a y. So now we want to see how many times can 2y go into 4y cubed. So let's do that. So 4y cubed over 2y, right? So 2 into itself 1, 2 into 4 goes 2 times, right? And now we want to see how many times y can go into y cubed, right? So y cubed divided by y to the first power, right, would leave us with y to the 3 minus 1, which is just y squared, right? So therefore, we're left with we'll just be left with y squared up here, right? So be y squared up here. So if you look, we have a 2 from which, when we see how many times to go into 4, which is 2 times 2y squared. So we'll write a 2y squared on the inside of the bracket, right? And now we want to see how many times can 2y go into minus 6y, right? So that will be minus 6y over 2y, right? So the y's will cancel each other, right? And 6 into itself 1, sorry, 2 into itself 1, and 2 into negative 6 will be negative 3, right? So that will just leave us with minus 3. So therefore, our answer will be 2y squared minus 3. Alright? So now, let us go to our next one, right? We can go to this one. 15 x squared y minus 20 xy squared. All right, so now what we need to do is to, if we realize we can find the HCF between 15 and 20, right? We can find the HCF between x squared and x, and the HCF between y and y squared. So let's start by finding the HCF between 15 and 20, right? So the factors of 15, right? Let's start by listing the factors of 15. These are 1, this is 3, this is 5, right? So 1, 3, 5, and 15, right? These are the factors of 15. The factors of 20, right, would be 1, 2, 4, 5, 10, and 20, right? So now we can take out the highest common factor between 15 and 20, which would be 5, right? So we can factor out a 5. And now we can go ahead to find the HCF between x squared and x, right? So the HCF between x, so first we can list the factors of x squared, right? Which are x to the 0, x to the 1, and x to the 2. Now we can go ahead to list the factors of x, right? Or x to the first power, which will just be x to the 0 and x to the 1. So if we were to look, our HCF between x squared and x to the first power would just be x to the first power x, right? So we can factor out x. And now we can we can find the HCF between y and y squared, right? Which is, we can call y to the first power. So the factors of y are y to the 0, y to the 1. Now we can go and factor out factors of y squared, right? Which are y to the 0, y to the first, and y to the second, right? And if we're to look, the HCF between y and y squared would just be y. So we can factor out y. So we basically factored out 5xy, right? So now we want to see how many times can 5xy go into 15x squared y. So we can write it as this: 15x squared y over 5xy. So basically 5 goes into itself 1, 5 goes into 15 3 times, right? And now x would go into itself 1 time, right? X goes into x squared, x to the first are x times, right? And y would go into itself once, y would go into itself once. So if we look, we're just left with 3x here, right? So 3x. And now we would see how many times can 5xy go into minus 20xy squared, right? So now we're going to do that, right? So that would be minus 20xy squared over 5xy, right? So 5 would go into itself 1 time, 5 will go into negative 20, negative 4 times, right? X will cancel each other, and y will go into itself once, right? Y go into y squared, y times, right? So if we look, we're left with minus 4 and y, so we can write it as minus 4y, right? Hence, this would be our answer. 5xy open bracket, 3x minus 4y. Alright, so that would be it for today. I hope you learned something new. Remember to like, share, and subscribe, and I will see you next time.